Welcome to the deep dive. Today we're going to try and cut through the physics of moving massive amounts of video data. We're taking a deep dive into active optical cable technology, and our source is the DVIGear DVI-25100 AOC HDMI cable. So the fundamental problem here, the technical wall, is pretty brutal. Your standard copper cable, it just can't push the 18 gigabits per second you need for 4K video over 100 meters. The signal just degrades into digital mud.
It does. It completely falls apart. And what's fascinating here is that they haven't just, tried to optimize copper. They've changed the medium entirely.
Right.
This is an active optical cable in AOC.
Yeah.
The whole strategy is to trade electrons for photons.
Electricity for light.
Exactly. High-frequency electrical signals, they lose power really fast. Light, on the other hand, is just so much more resilient over that kind of distance.
Okay, so let's unpack the performance specs that, really prove this works. For professionals, the image has to be flawless.
It has to be perfect.
We're talking HDMI 2.0 compliance, 3840 by 2160 at 60 hertz. And crucially, it handles 4.4.4 8-bit or 4.2.2 10-bit color. Why does that specific detail matter so much?
Well, it's all about avoiding compression. Any kind of artifact. 4.4.4 gives you the purest possible color information.
I see.
And the engineering behind that is this hybrid design. The cable uses these polyfluorinated optical fibers, POF, for the actual video signal.
Okay.
And then it uses 6 standard copper wires for the other stuff, like control signals and power. The optical part uses these 4 discrete light channels. Think of them like 4 dedicated highways for light, ensuring that video gets there stably.
That optical path immediately makes me think there have to be benefits beyond just conquering distance, right?
Oh, absolutely. So because the video signal is light, the whole system is basically immune to environmental electronic noise.
So for high-stakes applications where signal integrity is everything...
It's non-negotiable. And if you connect that to the bigger picture, it gives you a huge security advantage. By transmitting with light, the cable gives off almost no signal leakage. We call that a low RFI and EMI profile.
Right, radio frequency and electromagnetic interference.
Exactly. So it's perfect for secure environments like a government facility or a trading floor where you just cannot have signals being intercepted.
So performance is incredible, but installation, that's often the biggest headache. If this thing is so high-tech, is it like a massive, rigid pipe?
Not at all. And that's maybe the most surprising part. The materials are actually engineered for ease of use. They're plenum rated, which is a fire safety standard.
Okay.
And they're lightweight and really flexible.
Wait, how flexible are we talking? The source says the minimum bend radius is only 2 millimeters. I mean, that is unbelievably small.
It's tiny.
How do you even snake that through a conduit without breaking it?
That's where the most innovative part comes in. The HDMI connectors, they're removable.
Really?
Yeah, you could detach the whole HDMI plug, and what you're left with is this tiny little cable end. It measures just 12.4 by 10 millimeters.
Wow.
So that minimal profile slips right through narrow spaces, then you just reattach the plug on the other side.
And the final piece of the puzzle is power. You don't need a separate power brick for this.
In most cases, no. It draws the tiny amount of power it needs, less than 1/4 of a watt, directly from the HDMI source. It just simplifies everything. Fewer connections, fewer points of failure. So what you have is this rugged, compact, TAA-compliant solution that flawlessly extends these huge 18 GBP signals over 100 meters. The whole point is perfect image quality no matter what.
But that flawless quality, it does come with a price tag. The 100-meter version has an MSRP of, what, $1,195?
It's a professional tool.
It is, and it shows that the cost of extending high-fidelity video isn't really about the wire anymore. It's about the very advanced optical components and the engineering needed to get around the physics of electricity. So we'll leave you with this thought. What other common signal limitations might light be able to solve for us in the future if we're willing to pay for the engineering?